We will see in this video how to create piers with variable column. We have a library of column cross-section which works exactly the same way as for deck template or barrier templates or beam templates. That means defining the cross-section graphically, then assigning some constraints and the possibility to define some variables. We can check this variable. Here we have a simple column, so it's a square chamfered with a variable offset from the point of insertion, then different width and height on both sides, and finally we can change the size of the chamfer, going from a square or a rectangle to an octagon. So, if it's okay, we can go then to the library of piers and create a new pier. It's a multi-column pier, and in our case we will have two columns which are just defined under cap, with for each column the distance from the edge to the column. And for each the variable part, so we define it with a custom variation. Let's double click on this. So we define the template that will be the same all along this distance, and with this template we will define the variation of each variable. So the first one is an offset, which is the main variable, so it can lead the column to start almost to the extremity of the cap and going to the center of the footing. For a nice variation, we will ask a parabolic ending that gives that nice curve to the column. We can then change the different size of the square by updating, so half depth and half width of the cross-section of the column. Each time we can update the drawing and see how it looks like. After updating these different values, so here we just increase to make the column a little stronger, but still based on square. And finally, for the fourth part of the square definition, so updating from 45 to 75 centimeters. So here we see the column, and to make a small visual effect, we will also increase the chamfer so that the column goes from almost a square to an octagon at the base of the footing. We can do exactly the same on the second column, so we will speed up a little the process, but we change exactly the same variables with the same values, just because the offset from the edge of the cap is from the other side is just a little away from the first one. But you see here we have a linear variation, so our parabolic variation is just parallel. So we will just change the angle, the global rotation angle, which is an intrinsic variable, so from 0 to 180. So to rotate this or make a symmetrical of the one which is already in place. And if we update drawing, we can have a nice pier. If we want it a little more baroque, let's say, let's change with a rotation from the cap to the base of 90 degrees. That will give this very nice curve in space. So on one side for one column, the first column, and we will adapt the second column in a different way so it's symmetrical. So going to 0 to 90 degrees. And here now we have a very nice pier that we can see from different views, including top views. Maybe we can change the angle variation so to have a more equilibrated piers on both sides. So we change this variation. So the advantage of update, drawing and change, we can directly play with the different variable and see what is the effect of any change on the variable. So here, after changing the side of the rotation of the second column, here we get something much more equilibrated, and especially if we go here from the side or from the top, we can see it's perfectly equilibrated. So we can close this and now place a bridge using this pier. For that, we will use the wizard, the bridge wizard, by just using standard parameters, but changing the name of the piers that are placed with the new piers we have just defined, and just let's place it. And now we can review this bridge with our very nice pier that we have just defined with this new possibility of variation.